Hello guys, welcome to another video. Today we are going to work on a couple of problems at topic 6. So let's jump straight to the paper and see the solutions. The first question, it says that the question is about circular motion. The diagram shows a car moving at constant speed over a curved bridge. At the position shown, the top surface of the bridge has a radius of curvature of 50 meters. 18a. Explain why the car is accelerating even though it is moving with constant speed. We have circular motion. The speed is constant, but the velocity, it always changes direction. So, direction of velocity is changing. So if you have any kind of change in velocity, then you always will have acceleration. And in this case is the centripetal acceleration. So if the direction of velocity is changing, so the object it is accelerating. Just the theory that you already know. 18b. On the diagram, draw and label the vertical forces acting on a car in the position shown. So what we have to do here is to create the forces that are acting on the object. Something very simple. Of course, you're going to start with a weight. The weight here at the center of the object, you name it W, you have to label it, and then you have, of course, the other forces that are in contact with the car. And what do you have here? You have the contact between the road and the wheels, so you have normal to the surface force in both wheels. Label them as N. Now from here you know that the W, it needs to be bigger than the both of the normal forces, because you have to have a force downwards to create the centripetal force for your object to move in a circular motion. So be careful with the size of the arrows here. And 18c, calculate the maximum speed at which the car will stay in contact with the bridge. Now the maximum speed, it will be when the W, it will be equal with the centripetal force. Okay, otherwise, if you have a different expression on this one, then of course the car is gonna lose contact. So from here, what do you get? You have mass times gravitational acceleration for the weight, it is equal with the centripetal force. The mass times the velocity square divided by r. So from here, the masses are cancelled out. You want to find this maximum velocity, maximum speed. So you solve for V is G times R. You have everything here, you do the calculations, you find a value of 22 meters per second. And this is your maximum speed. Number 19, question about gravitational force fields. State Newton's universal law of gravitation. So what do you have to say here? Here you have to explain the law that it says that the attractive force between 2 point masses is directly proportional to the product of the masses, and of course inversely proportional to the square of the distance between them. So if you see the formula here for the Newton's universal law, it says G times mass divided by R squared. So you have to make these points product of the masses, be careful here, proportional to the product of the masses, not just the masses, and inversely proportional with the distance between them. Also, you need to state that the force is attractive. You need to state also that the masses are point masses. Just the formula here is also acceptable. 19b. A satellite of mass m orbits a planet of mass capital M. Derive the following relationship between the period of the satellite t and the radius of its orbit. Kepler's third law. So we need to derive this equation. So how do we start here? Here, of course, we know that this universal law of gravitation, this force, it should play the role of the centripetal force if you want to make the object to move around. So what do you get here? You have G times the mass of one times the mass of the other divided by the distance square, I use the letters here that I have, is equal with the mass of the one planet, of let's say the small planet, times the velocity of its planet divided by their distance between them. So here you get some cancellations, the masses and the distance. So you solve here for velocity. Velocity square is equal to g times capital M over r. But now you need somehow to include here the period, as you can see. So what do I know? I know that the velocity is the total distance covered under a specific amount of time. So if I take one revolution, what do I have? I have the circumference of the circle divided by the time, but one revolution is one period. So from here, what do? I include this into this one and I get, of course, v square, it's 4 pi square r square divided by t square, and all of this is equal to gm over r. And of course from here what I will do, I will solve for t square and I get t square is equal to 4 pi square r cube divided by gm. And this is how you derivate this expression, the Kepler's third law. Number 43. This question is about a probe in orbit. A probe of mass m is in a circular orbit of radius r around a spherical planet of mass m. State why the work done by the gravitational force during one revolution of the probe is zero. Okay, we need to be careful here, because if you remember, the work done given to an object is the force multiplied by the distance, but the force, it needs to have the same direction as the distance. Here we know that the force, it will always be inwards the center of the circle. So you see that the force here, it's always at right angles with velocity. So force always at right angles to the velocity. And of course this indicates zero work. 43b. Deduce for the probe in orbit that its speed is v equal to square root of gm over r. Something very simple again, whatever we did before, we equate the Newton's gravitational law with a centripetal force. So you have gmm over r is equal to m v square over r. So from here you do the calculations. So here is r squared. So you get v is equal square root of gm over r. Very simple to derivate this. Number 2, the total energy is given by this expression. Okay. So the total energy, what it is the kinetic energy plus the gravitational potential energy. Although the gravitational potential energy, remember, that is negative. So kinetic energy 1 over 2 mv square. Gravitational potential energy minus gmm over r. Now what do you have here? You have the expression for velocity, so I'm going to use this one, 1 over 2. V square is all of that, but without the square root, gm over r minus gmm over r. And you see that you have, of course, the same terms here and here. So you do the math here, and the total energy will be minus gmm over 2r, as the expression says here. And number 43c, it is now required to place the probe in another circular orbit farther away from the planet. To do this, the probe's engines will be fired for a very short time. State and explain whether the work done on the probe by the engine is positive, negative, or zero. So what is happening here? We move the probe farther away in a bigger orbit. So the total energy will be greater than before. Also, the probe produces a force that is to the same direction with the velocity, with the direction of the motion. So the same direction of the motion. So it's pretty clear from here that the work done, it will be positive. So that's it for today, guys. You need to study hard, understand everything in the topic, and good luck.